Once a highly classified capability reserved for government and military use, detecting and pinpointing RF emissions from space is now becoming a powerful tool in the commercial sector. Companies are harnessing this technology for surveillance, intelligence gathering, and much more. Interest in RF monitoring has surged, especially with geopolitical conflicts disrupting vital maritime shipping lanes and supply chains. This technology can track vessels, even those trying to evade detection, by shutting off their automatic identification systems, AIS. This evasion tactic is common among illegal fishers, smugglers, and other vessels engaging in illicit activities. By analyzing electronic signals from ships, aircraft, and other sources, companies can create electronic fingerprints of these vessels, identifying them even when they attempt to hide. James Sandy Winnefeld, a retired U.S. Navy admiral and board member of Hawkeye 360, explains, "We're only scratching the surface of what's possible with RF monitoring. It's a game changer for tracking dark ships and locating GPS jammers." Hawkeye 360, a Virginia-based company, is leading the charge with shoebox-sized satellites that listen for electronic signals. Their constellation has grown to 29 satellites, with more launches planned to enhance their capabilities. The applications of RF sensing go beyond maritime surveillance. On land, the proliferation of GPS, communication devices, and IoT devices generates a wealth of exploitable signals intelligence. From smartphones to vehicular communications, all this data holds significant intelligence value. You're going to see more RF processing capability, more frequency coverage, and greater sensitivity, says Winnefeld. One of the technical challenges they face is geolocating intermittent land-based radars, which are much harder to find. However, advancements are being made to overcome this hurdle. Different parts of the world have unique needs for RF monitoring. Hawkeye 360 is expanding its capabilities to meet these demands, deploying new clusters of spacecraft and testing advanced signals intelligence payloads. In April, the company's constellation grew significantly after launching 2 triplets into mid-inclination orbits optimized for monitoring busy shipping lanes. Later this year, they plan to deploy 2 more clusters of 3 spacecraft and test a new payload designed to collect more advanced signals intelligence. As the commercial sector embraces space-based RF sensing, competition is heating up. European startups like Aerospace Lab and Unseen Labs are launching advanced RF monitoring satellites, aiming to carve out their share of the market. Aerospace Lab, a Belgium-based company, recently launched its first trio of satellites equipped with RF sensing payloads. These satellites, similar to Hawkeye 360's, fly in a triangular formation, enhancing their ability to locate unique RF emissions from ground-based radar systems. French startup Unseen Labs is expanding beyond maritime tracking, developing satellites that can monitor emissions from land, air, and space-based sources. Their goal is a constellation of around 20 satellites in the next few years. Unlike their competitors, Unseen Labs geolocates RF signals using individual satellites rather than orbital clusters, offering a unique approach to RF monitoring. RF monitoring isn't the only game in town. Companies like Capella Space and IC are introducing synthetic aperture radar (SAR) capabilities for maritime domain awareness, detecting and identifying dark vessels. SR satellites use radar to create detailed images of the Earth's surface, allowing for the detection of objects and features that might be hidden from optical satellites. Winnefeld emphasizes that different types of space-based sensors work best when their data is fused together. Phenomenologies work best in a complementary fashion, he says. A prime example is the increasingly common tipping and cueing approach, where a satellite detecting a suspect RF emission from a vessel tips or cues another satellite with different sensing capabilities to take a closer look and capture high-resolution imagery. This data fusion approach is already being used in U.S. military and intelligence programs, where a prime contractor integrates data streams from multiple commercial remote sensing providers into unified situational awareness solutions. Despite its potential, the commercial sector faces challenges. Awareness among potential government customers about the capabilities of commercial RF services is limited, and existing defense budgets and procurement processes can hinder adoption. The military sometimes lacks visibility into what the commercial sector offers, Winnefeld notes. He suggests that companies offer pilot programs to defense organizations at little or no cost to showcase their electronic signals tracking abilities. To tackle these challenges, companies are increasingly adopting innovative strategies. For instance, pilot programs help demonstrate the effectiveness and reliability of commercial RF monitoring services. These initiatives allow defense organizations to test the technology in real-world scenarios, building trust and confidence in its capabilities. Additionally, collaborations between commercial firms and government agencies can facilitate the integration of RF monitoring into existing defense infrastructure, enhancing overall situational awareness. The transition of RF monitoring from classified to commercial use marks a significant milestone in space technology. As this market expands, the possibilities for innovation and intelligence gathering are boundless. Companies like Hawkeye 360, Aerospace Lab, and Unseen Labs are paving the way for a new era of space-based RF sensing, providing invaluable insights for maritime and terrestrial applications. One exciting development in the field of RF monitoring is the potential for real-time data analysis. Advances in artificial intelligence and machine learning enable the rapid processing of vast amounts of RF data, allowing for timely and accurate identification of threats. By leveraging these technologies, companies can enhance their ability to detect and respond to emerging security challenges. Moreover, the integration of RF monitoring with other remote sensing technologies, such as electro-optical and infrared imaging, can provide a more comprehensive understanding of the operating environment. This multi-sensor approach allows for cross-validation of data and reduces the risk of false positives, ensuring that critical information is accurately interpreted. Looking ahead, the commercial sector's role in space-based RF monitoring is expected to grow significantly. As the demand for reliable and actionable intelligence continues to rise, companies will invest in the development of more advanced and capable satellite constellations. These next-generation systems will offer enhanced resolution, broader frequency coverage, and improved geolocation accuracy, further solidifying RF monitoring's position as a vital component of modern surveillance and intelligence operations. Stay tuned to Galactic Gazette News for more updates on space exploration and technological advancements. Don't forget to like, subscribe, and hit the notification bell to stay informed about the latest space news. Until next time, keep looking up.